I'm Hyungjun Lee, a research engineer at Nota AI. This video demonstrates crafting a lightweight model using PyNetsPresso and the Yellow V5 Large. Before you proceed, make sure you have the PyNetsPresso library pre-installed and the pre-trained Yellow V5 Large model available. You can install the NetsPresso Python package using the pip method or manual installation from Nota AI's project GitHub repository. The Yellow V5 Large model used in this demo is the official version provided in Nota AI's GitHub repository. To start, import essential classes such as model compressor, task, framework, compression method, and the recommendation method from PyNetsPresso. Model compressor is a single class that effectively implements a variety of compression techniques. In the task field, enter the desired action from the supported options in PyNetsPresso, including image classification, segmentation, and object detection. Enter the framework to be used, choosing between PyTorch and TensorFlow Keras. The compression method specifies which pruning criteria will be used. In this demo, we use L2nom. The recommendation method provides options for suggesting individual layers, assuming pruning of a single artificial neural network like Yellow V5 with an overall pruning ratio ranging from 0.1 to 0.9. Declare compressor. Enter your NetsPresso account ID and password. Upload the pre-trained Yellow V5 Large model to the compressor server. Enter the model name in upload model name. Set the task as object detection and the framework as PyTorch. Enter the upload model path similar to the path shown on the left. Input shape is usually configured with batch size 1 and channel 3, while the dimension should be entered as a list. Enter the upload method in the compression class. This is the compression segment using the recommendation option. Enter a value for compressed model name and specify the compression method as compression method.pr.l2. The recommendation method utilizes a modified version of LAMP known as slamp. When it comes to the recommendation ratio, there are several options available. However, we have excluded the recommendation ratio for this demonstration to utilize varying ratios. For output path, enter the storage path for the compressed model. This is the compression segment. To compress through recommendation, input the model ID. The compression method and the recommendation method remains consistent with the prior declaration. We plan to use various ratios, so we have entered the ratio for the recommendation ratio. To ensure separate compression for each ratio, the format has been declared as ratio. Enter print to verify the success of compression. Run the code to check the model uploading process. The upload is complete. You can efficiently perform future compression using the model ID with the same model. Once the model upload is finished, the compression process will commence. The model has successfully compressed at a rate of 10%. Compression is applied to each ratio. The compression for the 9 options has been completed. The .bt file for the completed task model will be stored in the designated path. The compression with PyNetsPresso has been completed according to the entered ratio for the YOLO v5 large model, creating a lightweight model. For optimal performance, it's essential to retrain the compressed model. This can be accomplished by utilizing the YOLO v5 repository offered by Nota AI, effectively restoring the performance of your custom dataset.